This is Science in Action from the BBC.
Altogether, I have had 4 shipwrecks and a fire during my 30-odd years at sea. But by far and away the worst of them all was the loss of the Titanic, the biggest and finest ship in the world.
In 1912, the Titanic struck an iceberg in the North Atlantic Ocean, and that unsinkable ship sank. Now, the glacier blamed for producing that fatal iceberg is pushing more ice into the sea and moving at a record rate. Although the danger to ships is probably less than it was 100 years ago, the danger to the planet as a whole is that sea levels will rise dramatically. The Jakobshavn Glacier in Greenland is slowly moving off the land and disintegrating into giant ice shards in the sea. Professor Ian Jockin, glaciologist at the University of Washington in Seattle, looked at satellite images to map how quickly the glacier was retreating. As he reports in the journal Cryosphere, he's been looking at this over the last 10 to 15 years, and the speed is increasing.
Snow falls every year in the middle of the ice sheet, and on average you have to remove that much snow or ice from the ice sheet. And so what happens is it falls in the middle and it spreads out toward the edges. And when it reaches the coast, if it encounters land, then it'll sort of stagnate there and melt. Or if it finds a fjord where it can discharge through, it will calve off as icebergs into the ocean.
Now, typically this is a very slow process, hence our expression of things moving at a glacial pace. But this particular glacier seems to be moving a lot faster.
Indeed it is. In the 90s, it was moving at about 6 kilometers a year, which at that time was the fastest major glacier in Greenland or Antarctica. It's managed to retain its title by speeding up to 17 kilometers a year in the summer and somewhat slower than that, 10, 12 kilometers a year during the winter.
Now, does that worry you? It sounds concerning to me that it should have sped up quite so much in that period.
Well, the problem is when it was flowing at about 6 kilometers a year, it was putting enough ice into the ocean to just about balance the amount of snow that fell each year. Now that it's sped up, it's producing somewhere between 2 and 4 times as much ice, and that excess ice is getting discharged into the ocean, and it's causing sea level to rise. So from this one glacier alone, over the last decade, it has raised sea level by about 1 millimeter.
So what's actually going on here? Is it just melting faster?
Well, it's not so much melting. Greenland is losing a lot of extra ice from melting these days as well. But it's as the temperatures have warmed, the glacier, through a number of processes, has sped up, probably because the warmer ocean was melting the underside of the glacier, and there was less sea ice in the fjord to restrain the glacier. So it's sped up a lot, and that, again, discharges far more ice into the ocean than can be accommodated by the snowfall. Now, if this were only one glacier, an isolated glacier in Greenland, we might not worry so much, but there's a couple hundred glaciers in Greenland, and when we look at it, large populations of them, on average, they've sped up by about 30%. This one is a bit of an outlier with its really dramatic speed up, but it's not the only one speeding up.
I'm interested in the actual physical process that's going on here. Are they somehow sliding more easily because the underside is warmer?
No, that's something there's been a lot of concern about, and we've done a lot of work up there to show that the slower-moving ice sheet does speed up a bit in the summer, and there's been a lot of work in Britain actually looking into this as well. What we find out is that there's some transient summer speed-ups, but they're confined more to the slow-moving ice. What's happening with this particular glacier is that every summer it retreats into deeper water, and when it's in deeper water, you can think of it as being in a deeper ditch or a pipe that the ice is flowing through, and there's less restraint. And so if you have a bigger diameter pipe, you can move more ice and faster, and so the ice tends to discharge more. And then over time, each summer the glacier's retreating back further, about 600 meters deeper into the ice sheet each year, which is causing it to speed up.
And the global implications with this rise in sea level could be very serious.
Yeah, I think I just read a story recently that you have a lot of flooding in southern England right now. So a millimeter might not sound much, but collectively the millimeters add up, and those areas like that and Bangladesh have a heavy impact over the years as sea levels rise.
The other story that we've heard a lot when it comes to ice was on the other side of the world with that ship with the scientists and our reporter getting stuck in ice in Antarctica. So there is ice forming elsewhere. Are these processes linked? Is there a bigger picture here?
Antarctica is a different story because there's very little surface melt, rarely melts, and so most of the ice that's lost in Antarctica is a calving of icebergs. That's why in Antarctica you hear about these sort of New England-sized state, Rhode Island-sized state icebergs breaking off because they can't melt, so they have to break off into the ocean. But as the ocean's warmed, some of that ice flows off the ice sheet and hangs into the ocean, and that warmer ocean is melting that ice rather rapidly. And so in Pine Island Bay and Thwaites Glacier and these other glaciers in Antarctica, on the western Antarctica, there's a big concern about those destabilizing. And the problem with those is, unlike Jakobshavn, which does eventually retreat out of its basin, those glaciers are sitting in kind of a big bowl, and the deepest parts are in the center of the ice sheet. So in some sense, once they start to flow quickly, the next stable state may simply be no ice sheet at all. And in that case, we're looking at several meters of sea level rise over some period of a few centuries to several centuries.
Professor Ian Jockin.
Thank you for downloading from the BBC. For details of our complete range of podcasts and our terms of use, go to bbcworldservice.com/podcasts.